In this video, we'll break down absolute value functions and equations, what they look like, how to solve them, and how to graph them. So let's get into it. So what is absolute value? The absolute value of a number is the distance from 0 on the number line. It is always non-negative. So let's say we have the absolute value of 3. This will equal 3. And the absolute value of negative 3 will also equal 3. So now let's look at solving absolute value equations. Let's say we are given the absolute value of x minus 2 equals 5. What we're going to do is we're going to split this into two cases. The expression inside the absolute value could be 5 or negative 5. So we'll have x minus 2 equals 5 and x minus 2 equals negative 5. Then when we solve for x, we will get x equals 7 over here and x equals negative 3 over here. So the solution set will be x equals negative 3 and 7. Now, one thing to watch out for is the absolute value can't equal a negative number. In this case, there is no solution. So let's say, for example, we have the absolute value of 2x minus 1 equals negative 4. There would be no solution. The absolute value of an expression cannot equal a negative number. Now let's look at graphing absolute value functions. Let's look at the function y equals the absolute value of x. Now, the best way to look at this is with a table. This function takes any input x and returns its distance from 0. So whether x is positive or negative, the output is always non-negative. So let's set our table up with our x and y. And let's say our x is negative 3, the y will be 3. Negative 2, our y will be 2. Negative 1 will be 1. 0, 0, 1, 1, 2, 2, 3, 3. Plotting these points will give us a clear shape of a V. So let me draw the x and y axis. And let me change the color. So our vertex will be at the origin 0, 0. So right here. And then we're going to have points at 1, 1, 2, 2, and 3, 3. So plotting this, it'll look like this. So negative 3, 3, negative 2, 2, negative 1, 1, then 0, 0, then 1, 1, 2, 2, and 3, 3. So our graph looks like this. Notice that the graph is symmetric across the y-axis. That's because the absolute value is the same for both positive and negative inputs. Just like other functions, absolute value graphs can shift. So let's look at the parent function y equals the absolute value of x. We can shift this graph like y equals the absolute value of x minus h plus k. This will shift the graph right by h units and up by k units. Now we can flip the graph over the x-axis by doing y equals the negative absolute value of x, right? And this will flip over the x-axis. And we could, let's say, make it steeper by multiplying the absolute value of x. So there are some of the transformations you can do. So now let's look at solving absolute value inequalities. The key with inequalities is to rewrite them without absolute value bars. So let's say we had the problem, the absolute value of x minus 1 is less than 4. Our first step will be to write as a compound inequality. So negative 4 is less than x minus 1, which is less than 4. Now we'll solve for x, so we'll add 1 to both sides. So we'll get negative 3 is less than x, which is less than 5. And that is the answer. On a number line, it would look like negative 3 and 5. And there you go. So now let's do some practice problems. You complete them and then watch my solution. So the first one, the absolute value of x plus 4 equals 7. So to complete this problem, we will set this up as two different problems. So we'll have x plus 4 equals 7 and x plus 4 equals negative 7. We'll solve for x. So we'll get x equals 3. And over here, we will get x equals negative 11. So the answer would be x equals negative 11 and 3. So for the second practice problem, we will do the inequality. The absolute value of 2x minus 1 is greater than 3. Since this is a greater than problem, we're going to split it into two separate inequalities. We'll have 2x minus 1 is less than negative 3, or we'll have 2x minus 1 is greater than 3. Now when we solve, we'll add 1 to both sides. So we'll get 2x is less than negative 2. And over here, we'll get 2x is greater than 4. Then we'll divide by 2. And then we'll get x is less than negative 1 and x is greater than 2. So the answer would be x is less than negative 1 or x is greater than 2. So for practice problem 3, the last practice problem, we'll do a less than problem. So the absolute value of 3x plus 2 is less than 5. So what we're going to do is, since it's a less than inequality, we can do a compound inequality. So we're going to split it as negative 5 is less than 3x plus 2, which is less than 5. Now we will subtract 2 from all sides. So we'll get negative 7 is less than 3x, which is less than 3. Now we can divide by 3. So our answer will be x is greater than negative 7 over 3, but less than 1. And that is the answer. That wraps up absolute value functions and equations. If this helped, feel free to like and subscribe for more videos. And thank you for watching.